Why hello lovely humans, Jen Foxbot here. Welcome to another edition of Math Mondays, da 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 da, yeah! Alright, so today we are going to tackle the question of how much CO2 have humans put into the atmosphere. Ooh, it can be a little bit of a scary and unnerving topic, so I just want to say that after we walk through the mathematics of how much CO2 we have put into the atmosphere, we will talk about different ways that you and I and individuals all around the world can help to mitigate climate change. And just remember that there is always hope. There are always things that we can do as an individual. And when we band together with other people, we can have a much, much bigger impact. So in teaching y'all about CO2 and climate change, just remember that this is so that we can know what we can do to help fix the issue. Okay, so I also want to start off by saying that the atmospheric levels of CO2 are at the highest they have been in 15 to 20 million years. That's a very long time, and humans were not around then. So that's one of the major issues, is that we don't know what is going to happen to us when we have levels of CO2 that we haven't literally ever experienced. We don't know what's going to happen to other living creatures or the climates around the world. This is a global problem, but it's going to affect our local environments in very different ways. And climate is really complicated, so it's kind of impossible to predict with certainty exactly what is going to happen in different areas. And that makes it very difficult to prepare for. So it's in understanding how we mitigate climate change, it helps to understand the scale of the problem. Okay, so the other thing that I want to mention is that before the Industrial Revolution, which happened in the mid-1800s, natural carbon emission and absorption by forests, soil, and oceans were mostly in balance. And it wasn't until humans started putting excess CO2 into the atmosphere that we threw off that balance. Before we started doing that, this natural absorption and emission was relatively stable for thousands and thousands of years. And we know all of this because we can look at ice cores and we can pull out carbon from those ice cores and analyze it. I'm not a climate scientist, so I'll kind of leave it there. But if you want me to talk more about how we can calculate historic levels of CO2, I'm happy to do a video on that as well. But yes, so that's all to say that we know that the current levels of CO2 in the atmosphere are unprecedented since humans have been around. And humans came about maybe like a million years ago. Okay, so now the question is, what do those natural carbon emission and absorption cycles look like? Well, let's draw a little picture. I'll put on my my Bob Ross wig and draw some trees. Yay, trees! Boop, beep, 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 beep. That's a funny little tree. Maybe we have a willow tree. Oh, cute! And because I'm in the Pacific Northwest, of course we have conifers. So this is land. So we'll say land and vegetation, vega for short. And then over here we have the ocean. Oh, maybe over here. Wow, onward! Or I could put a ... to say that it keeps going. So this is our ocean. And so the land emits about 439 gigatons per year. Quick note that giga is 10 to the 9th, or 10 billion. It's a very big number. And the ocean emits about 332 gigatons per year. Okay, so they emit a lot of CO2 per year, but they also absorb a ton, or gigatons, sorry, terrible pun. Okay, so land and vegetation, aka forest and soil, absorb about 450 gigatons per year. I'm gonna erase this so it doesn't get in the way. and the oceans absorb about 338 gigatons per year. Okay, cool. So you can see that even though the Earth and the ocean emit a lot of CO2, they also absorb even more. And so this is why the emission and absorption cycle of natural CO2 was mostly in balance for a really long time. But then humans, us clever little humans, oh yeah, come along and we built a lot of factories and we burned a lot of fossil fuels so that we could, for good cause, so that we could bring electricity to homes and plumbing and all that good stuff. Is pretty rad. But since the Industrial Revolution, we have been emitting on average about 29 gigatons per year. Okay, you might be saying, 29 in comparison with 439 and 332 is not that much. And you're right, relatively speaking, in comparison, it's not more than the Earth and the ocean combined. And you might also note that there is some excess here, so we're all good, right? Well, before we make any assumptions, let's use our math skills to actually figure out how much excess CO2 humans are putting into the atmosphere. So to do that, we need to add up all of the CO2 that is being emitted from all of these three sources. We'll add up how much is being absorbed, and then we'll subtract the two to figure out the difference. All right, here we go. So we're gonna make a little table. On one side, I'm gonna say emitted. On the other, absorbed. I always wanna spell this word wrong. And so the land emits 439 gigatons. We'll say, I'm going to put my units above here, gigatons per year, and also there. And it absorbs about 450. And then we have the ocean, which emits about 332 gigatons per year and absorbs about 338. And then we have us little humans, which emit about 29 gigatons per year, and we absorb nothing. Yeah, good for us. Okay, whoops, an extra little line there. Okay, so when we add up all of the CO2 that is being emitted into our atmosphere, we get about 800 gigatons per year. Let me see if I can write that bigger. So 800, that's a lot. How much is absorbed? Well, if we were to add this up, we would get about 788 gigatons per year. Okay, so now we can actually see with certainty that we are emitting, or well, and when I say we, I kind of mean the Earth collectively plus humans. We're all emitting a little bit excess. And so what's the difference? Well, it's 12 gigatons per year. All right, so now I'm saying 12 gigatons, that's not that bad. But wait, we have been emitting an excess of 12 gigatons per year for about 120 years. Okay, so this is where it gets a little unnerving. When we multiply by 120 years, so we have 12 gigatons per year times 120 years. What does that equal? I'll give you a second to do the calculation. That is 1,440 gigatons of CO2 that we have put into the atmosphere that have not gone anywhere. It's just hanging out. That's a problem, because what scientists have discovered in doing simulations and various experiments, they have found that CO2 acts like a blanket. It traps heat in our environment. And so now all of a sudden, we have increased the levels of CO2 to over 100 parts per million. And just to give some context, we have done that in less than 120 years, whereas a natural carbon cycle, to increase the level of CO2 to 100 parts per million, it would take between 5,000 and 20,000 years. So humans have done this really fast. So not only are the levels of CO2 in the atmosphere increasing, but the change is accelerating. It's happening faster and faster and faster every single year. And that makes it really, really, really hard to predict how our excess carbon is going to affect our local climates. Okay, so that is a lot of excess carbon, and remember that giga is a billion. So we have put in a lot of excess carbon that is just sitting there. So that brings me to mitigation. Woohoo! Okay, so I want to be clear. There are kind of two issues that we talk about when we're talking about mitigating climate change. So the first is becoming carbon neutral, aka reducing humans' contribution of 29 gigatons per year to zero. But let's keep in mind that even if we became 100% carbon neutral, if we dropped this number down to zero, that would be amazing and it would help a lot. That still does not get rid of our carbon debt, because we still have this excess of 1,440 gigatons that's sitting in the atmosphere. So as individuals, it's really important for us to reduce the amount of CO2 that we are contributing. And I also want to point out that individuals aren't really the problem. It's large corporations. So just be clear on that. There are plenty of research studies that point to, who and what companies are doing this. I'll do another video on that, but it's a whole nother topic. But as individuals, there are things that we can do to change our behavior to reduce the amount of CO2 that we are contributing. One of the biggest things we can do is to have fewer kids. Another really big thing is to travel less, because airplanes emit a lot of fossil fuels. We also can improve the efficiency of our homes and businesses, because heating and cooling our buildings contributes, I want to say, about 40% of greenhouse gases. So that's a really big number. So just by making our homes and buildings more energy efficient, we can reduce our CO2 emissions. We can also take public transit and bike and walk and use other forms of transit that do not contribute as much CO2 as gas-powered cars. If you're able to, you can buy an electric vehicle. If you're able to, you can install solar panels on your house or use a solar hot water heater. And also we can buy used clothing and used goods, both in our homes and for our businesses, because manufacturing also emits a lot of fossil fuel emissions, or also emits a lot of CO2 emissions. There we go. Okay. But as individuals, one of the biggest things that we can do is join other individuals and talk about these things, talk about the ways that we can mitigate climate change through our actions, and then use our power in numbers to make demands of our representatives. And really mitigating climate change is going to need to happen on a societal level. So the good news is that we have a lot of technology to mitigate climate change. Renewable energy has greatly improved over the last 20 years. In fact, it's actually cheaper to build a new solar panel power plant than it is to maintain an existing coal-fired power plant. So in terms of economics, it actually makes a lot of sense to switch over to renewable clean energy. And also our infrastructure is a little old, so we have to update it anyway. Might as well make it better with renewable clean energy. But at the end of the day, it's really about knowing the issues, knowing how we are contributing, and knowing how we can mitigate so that we can actually implement smart and effective solutions. Cool. Okay, so I'm going to leave it there for now. Please let me know if you have any questions about how humans are contributing CO2 emissions. If you have any questions about renewable energy technology, that is one of my favorite things to talk about. Or if you want to learn about climate change, or if you have other math topics, have at it. All right, so thanks very much for watching, and we'll see you next time. Bye!